name is Silveru Upendar, Assistant Professor in the Department of Pharmaceutical Engineering, B.V. Raju Institute of Technology, Narsapur. Course name is Principles and Applications of Heat Transfer. Topic name is Heat Transfer through a Hallow sphere. Heat transfer through a Hallow sphere. This is the cross section of Hallow sphere. In this, here we considered a Hallow sphere. Inside radius of Hallow sphere is Ri. Outside radius is Ro. Thermal conductivity of Hallow sphere is K. Ti is the inside surface temperature of Hallow sphere. To is outside surface temperature of Hallow sphere. Here heat transfer is occurring from the inside surface of the Hallow sphere to outside surface in the direction of R. So Ti is greater than To. To derive the heat transfer rate equation for a Hallow sphere, we consider a spherical element at the radius R with the thickness of dr. First we write the Fourier's law of heat conduction at steady state. Equation is minus qa dt by dx. Here heat flow rate occurs in the direction of R, so the equation becomes Ka dt by x is replaced by R. Surface area of the Hallow sphere is 4 pi r square at radius R. Then the equation is minus K 4 pi r square into dt by dr. Here separating the variables radius and temperature, the equation becomes dr by r square is equal to minus 4 pi k divided by q into dt. For this equation, if we integrate both sides, with the limits, the lower limit is Ri, upper limit is Ro, dr by r square is equal to minus 4 pi k divided by q into integration for dt. Lower limit is Ti, upper limit is To. After integration, left side minus 1 by r with the limits of Ri and Ro, and right side 4 pi k divided by q. Integration of dt is t. Lower limit is Ti, upper limit is To. After substituting the upper limits and lower limits, the left side term is this, and right side term is q is equal to To minus Ti. Then if we multiply this minus into this bracket and left side and right side, the equation becomes 4 pi k by q into Ti minus To. This we got finally this equation. Rearranging this equation, and q is equal to 4 pi k divided by 1 by Ri minus 1 by Ro into Ti minus To. We can write this equation. Ti minus To divided by 1 by Ri divided by 1 by Ro divided by 4 pi K. This is the temperature difference, which is the driving force, delta T divided by the thermal resistance for heat transfer through a hollow sphere. This is the final derived equation. We can write this above equation like this also. But rearranging the above equation, we can write in the general form as heat transfer through a flat plate. The equation becomes like this. Here the AM is mean surface area of hollow sphere, 4 pi r m square. Rm is mean geometric radius, that is square root of Ri Ro. We can represent this heat transfer rate to a hollow sphere in the thermal circuit form, where this is the inside surface temperature, TO is outside surface temperature, and resistance R is equal to 1 by Ri minus 1 by Ro divided by 4 pi K. This is the derivation for heat transfer through a hollow sphere. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.